and we're going to find the interval and radius of convergence for a power series. Again, today is our last day of section 10.4. Then we'll move on to section 10.5.
Darn it.
We have been taking multiple days for each section, though, because they are kind of
Challenging, tricky,
intense sections. So first, if we're going to find the interval and radius of convergence of a power series, we need to know specifically what we mean by a power series. So a power series is an infinite series of the form, and it's a series we've already worked with. We just didn't call it a power series until now. N equals 0 to infinity, a sub n, the sum of a sub n times x minus c to the n. Maybe that's me. I thought I was on silent, but nope, not on silent. Sorry.
Oh my gosh.
Just going to put it on silent instead of vibrate. Okay, so infinite series of this form. So we've seen a couple of examples of power series already. What does this look quite a bit like? One of our formulas. Does this look quite a bit like? If I were to write it out, I'd have a sub n, you don't have to write this, but just to show you, a sub n plus a sub n times x minus c plus a sub n times x minus c squared plus...
that's like the Maclaurin series.
Okay. It looks an awful lot like a Taylor series, except they don't specify that that has to be a specific coefficient. The Taylor series, that had to be a very specific coefficient. I could also think of it as a geometric series. So we've already worked a lot with two different kinds of power series. Now something that wouldn't be a power series, so we know power series, just some of them are geometric, Taylor. There can be more, that's just the ones we've worked with specifically. But there's more things that can be called power series besides just geometric and Taylor series. Some of them don't have a specific name except for power series. Something that's not a power series would be x squared times x to the n. We don't consider that a pair. Well, let's do x minus a to the n. We don't consider that a power series because we can't multiply that a sub n. It can be anything with an n in it, but it can't be the variable x. Remember, n is kind of a variable, but it's following that pattern of we plug in 1, plug in 2, plug in 3. So we consider it more of a coefficient than a variable. Whereas something like this would be considered a variable in and of itself. Or if I just did the sum of sine is not a power series. There's a whole bunch of things that are not power series. So, if we're going to be able to find the interval of convergence, we need to know what we mean by that. And we've seen it a little bit. Mostly for geometric series have we seen this interval of convergence. The interval of convergence is the interval where the series matches the function. we graphed a whole bunch of times where we took a function and we graphed that exact function, and then we graphed a Taylor polynomial of like degree 4 to see how closely it matched. And usually it only matched for a little piece of the graph and not the entire graph. And that's our interval of convergence, where it actually matches the graph exactly. But usually it only matched part of it. I feel like we should graph it again just to get the visual of it as well. I'm going to pull up my graphing software so we can make sure we have the visual of that while the software is pulling up. Let's also talk about the radius of convergence. The radius is directly related to the interval of convergence. The radius, we get it from, so comes from the center of the interval to either outside bound in other words, it's half of the interval of convergence. But we're thinking of it in an absolute value way, so the radius of convergence would never be negative. Why are you... Okay. So we saw this when we were working with geometric functions, with geometric series. So what was the sum of a geometric series? Sum of a geometric series.
Oh, it was A divided by
A over 1 minus R. So if we do the most simple geometric series we can think of, that's just x to the n. So if we graph the function you'd get from that geometric series, we have 1 divided by 1 minus x. We had that function. If we graph the Taylor, or the polynomial that would go with that, we'd have 1 plus x plus x squared plus x to the third. We're going to go pretty decently. I mean, we can't graph the infinite one. So we're going to go, let's go to the 6th, just so we make sure it matches pretty well. And we see a polynomial that matches pretty well from -1 to +1. But what happens everywhere else? Nothing going on at all. So the interval of convergence for this function would be -1 to +1. That's where my polynomial matches my graph. The radius of convergence would be half of this interval. If my interval goes from here to here, my radius is from the center to either outside bound. So what's my radius of convergence for this one? 1. So just so we're getting the general idea of what we're meaning by this interval and this radius of convergence. So let's say we have this function. X minus 5 to the n over 6 to the n. The sum of that from 0 to infinity. We want to find the radius and the interval of convergence. So the ones we worked with most often was that geometric series. If we can recognize those geometric series right off the bat, even if they're written differently, we can work with them just like we've been working with them before. So I need to recognize right off the bat, this is geometric. It looks a little bit weird. We're going to have to rewrite it. How can I rewrite this function?
Since they're both to the end.
Since they are both to the n, we can put the entire thing to the n. Now we already knew something about the interval of convergence for a geometric series. We already knew something about the ratio. When did the ratio tell us that this converged?
When it was less than.
When it was.
Yeah, the absolute values.
So it converges if absolute value of r is less than 1. So according to this, what is r?
R is the x minus 5.
This stuff is r. So if we absolute value this stuff, x minus 5 over 6, and set it less than 1, this is going to help us find our interval of convergence. Now we could just go straight to writing this as -1 less than this piece less than 1. But that will only help us find our interval. To find our radius of convergence, we want x to have a coefficient of 1, which it looks like it does right now, except we're dividing by 6, so really the coefficient of x is 1/6. So we can find the radius if x has a coefficient of 1. So we've got to change something about this in order to find the radius. Well, I'm working with absolute value. I can't split up the absolute value bars if it's plus or minus, but I can if it's times or divide. Just like with radicals. I can't split up radicals if it's plus or minus, but I can if it's multiply or divide. So I could write this as absolute value of x minus 5 over absolute value of 6. What do we know about the absolute value of 6? It's 6. So I could move the 6 to the other side now so that I can have a coefficient of 1. How am I going to move the 6 over? Times both sides by 6. I'm running out of room, so I'm going to write this over here. Once I have that variable being a coefficient of 1, this number here is my radius of convergence. Now I can split this up to find my interval of convergence. When we have absolute value, how can I drop the absolute value bars? I've got to add something to the other side in order to do that. What do I put on the other side?
Oh, greater than.
Okay. -6. if I just solve this for x, I get my interval of convergence. So add 5 to both, or all 3 sides. We get -1 less than x less than 11. That's my interval of convergence. So radius of convergence and interval of convergence. So if it's a geometric, pretty straightforward, pretty easy. Just identify what is r, make it less than 1. So our next question is, what if our series is not geometric? So when we're geometric, we can't have our coefficient be an n. It would have to be just an actual constant. So again, the instructions would be, I didn't write the instructions a second time because it's still, what's the interval and radius of convergence. Now to do this, we're going to apply the ratio test using absolute value. And all the stuff I've been reading on this didn't really explain very well why this will give us the interval and radius of convergence, but it will give us the interval of convergence, so I know that's what we do, I just don't know why we do it. Okay, so if we apply the ratio test, what's the ratio test start out with?
The n plus 1.
N plus 1, what's before that even? The limit, right, as n approaches infinity. The part we want to leave off because we're lazy and it doesn't affect most of the problem, just the very end of the problem. Limit as n approaches infinity. Now we're going to be absolute valuing this entire thing. So we have n plus 1, x to the n plus 1, over 10 to the n plus 1, times, and then we flip the other fraction, because really it's divide by nx to the n over 10 to the n, but we kind of skip that step to make our lives a little bit easier. So we flip the fraction. What do we know about n, though? What is n really?
N plus 1.
Well, we have plugged in n plus 1, but what if I were to actually split up this series? What kind of numbers do we plug in for n? What would I plug in first?
Oh, 0.
0, and then
1,
1,
2,
2, 3, 4.
5.
So what kind of numbers are those numbers? Whole numbers, besides that. Positive numbers. They are whole numbers, but they're also positive numbers. What is absolute value going to do to a positive number? Nothing.
Keep it positive.
Keep it positive. So the n's aren't really affected by absolute value. Affected? No, I think it's E. I never know the difference between the one with the E and the one with an A. A?
Yeah.
I don't know which one. Absolute value. That is one thing I just can never remember. Which means I really only need absolute value around my x pieces. I don't need absolute value around the entire thing. We can drop the absolute value bars except around our x pieces. But now we still need to simplify. What can we currently simplify? 10n and the 10n plus 1 would be 10 to the first on the denominator.
And then the x
Absolute value of x to the n plus 1, absolute value of x. So those cancel, but it's left in the denominator because the n plus 1 is in the denominator. These cancel, but it's left in the numerator. I was a little sloppy, that n is still there. It's left in the numerator. And then n plus 1 over n, we leave the same. They can't cancel as they are right now. So we can apply L'Hopital's rule, or we could do that clever form of 1. I could just multiply top and bottom by 1 over n. Now what happens if we plug in infinity into n?
You get 1 over 1.
You get 1 over 1 over here.
Oh, on that side, yeah.
So we're left with absolute value of x over 10.
Is that an A? Or is that an N? Or is that a
Probably an
simple
N.
Absolute
There's-
value of X.
Yes, that is an n absolute value of x, but I was sloppy and it looked like it canceled out. Really,
Oh.
just that should have canceled out. So I was circling the n to say that's still there. My line got sloppy. Okay, this is still going to be less than 1. We've got to go through that entire process in order to figure out what this piece is, but we still make it less than 1, just like what we did with our geometric series. So it's less than 1 times both sides by 10. So what's our radius of convergence going to be? So radius of convergence is 10. What would our interval of convergence be? Negative 10 to 10. We don't even have to do any math after that. We just have to split it up. That's our interval of convergence. So there's 2 special cases. That's pretty much what you're going to do on every single problem, is either identify it as geometric or do the ratio test. So there's 2 special cases, and we still start with the ratio test. The only difference is going to be our conclusion at the end. I want to make sure everyone has it written down before we move on.
What's the R stands for?
Radius of convergence. That was just lazy and didn't write out radius of convergence because it's a lot of writing already. Thought you were raising your hand for a second. But you were distracted.
I didn't work on them or anything.
So instructions are the same. Find the interval of convergence and radius of convergence.
I need to sign it.
Oh, I thought it was an assignment that you were turning in.
How many classes is this one?
This is calculus, so it's really, really hard. You're 2B, right?
Yeah, can you send the other page too? Thank you.
So, how do we start these? What do we do every time to start this problem?
Limit.
Limit as?
Yeah.
Yes. I thought you said limit for a second, so I was like, wait.
You're like, what? No.
Limit.
I said limit, and she thought I said win. It. Like LN.
Oh,
It.
shit.
And then we're doing ratio. And technically we're absolute valuing the whole thing, but we can skip to the fact that we just really need absolute value around the x. Now this is one of the few times where we're not going to automatically flip something. I'm going to divide just by n factorial the value of x to the n.
Oh, 'cause.
Gotcha. Wasn't a fraction to start with.
Yeah.
So we simplify. What will it look like when we simplify?
X. Also known as X. And plus.
n plus 1, absolute value of x, or absolute value of x, n plus 1. It doesn't really matter the order. So now what's going to happen if we plug in infinity?
It's gonna be infinity.
What do we know about when it comes, because there's no other way for us to do this. There's no slick tricks we can use. It's going to come out infinity. What happens when we come out infinity? Okay? The limit doesn't exist, so our series would diverge. Now we have one special case. What could I put in for x that would make it converge?
Wow.
0.
I was gonna say 1 over n, which would have been 0 anyway. So.
0. So this means that particular series diverges everywhere else except 0. It only converges for 0. So its radius would be 0, and its interval of convergence is x equals 0. The radius, we don't have an interval in order to cut in half, so the radius is 0, the interval is also 0. Now if the number I had plugged in, like if this was x minus 2 inside, and x equals 2 is where it would be 0, my radius is still 0, but my interval would be x equals 2, because it's true only for the x value of 2. So one last example. Sorry, we're not going to have much time to work on the homework in class today. First of all, hopefully looking at that series, you should be thinking, that looks familiar. Why does that series look familiar?
Because you can. Oh. Isn't that like e to the x?
That is e to the x. Good job, guys. Okay. What do we know about e to the x? Where does e to the x converge?
It
Converges for
isn't it.
what values of x could I plug in, or what values could I plug in for x and it would still converge?
Isn't it like. Is it negative?
Anyway, everything. It converges for everything. So when we do this one, whatever result we get, we know that result should tell us it converges everywhere. So let's try it. Limit, and then goes to infinity. X to the n plus 1, absolute valued. N plus 1 factorial. This time I can automatically flip n factorial over absolute value of x to the n. We simplify. Hopefully this simplification of the factorials and these exponential things is becoming second nature. X to the first over n plus 1. Now what happens when I plug in infinity?
It's does that make it 0?
That makes it 0. That means we converge no matter what x is. We converge all the time. So this series converges no matter what. Yep. Sine and cosine converge. If we went through and did this process, although taking the limit of that would be a little bit harder, I'd have to look in how we take the limit of that. Well, it probably would end up with like cosine x over n plus something, and then we'd get 0 as well.
Yeah.
That's probably what would happen. I've never tried it, so don't quote me on that. So this series converges no matter what x is, which means our interval of convergence, all real numbers, everything. You guys know that symbol, right?
Yeah.
Okay. Again, it's just mathematicians being lazy, so we don't have to write the sentence. All real
All
numbers.
real numbers.
And then the radius of convergence.
Yeah, I just
never
gotten that. We've been doing this for like 2
I
years.
just put that together. It looked like an R to me the entire time. I just put it
There is
together.
an R in there.
She didn't know there was a double
Well,
bar.
like,
No,
I
she
did,
did. She
but I
was
just
like,
I didn't really think
lines are like the L's in there.
Oh. I just got it. I just put it together. Okay.
Oh my goodness, she just thought it was like a symbol.
This is
Yeah,
Symbol,
it
but-
is.
Well, yeah, but you just didn't put that Y
I
because
didn't
it's
really
that.
think about it. I just wrote it down.
Okay. So your homework. Still page 515.
Oh my gosh.
Didn't we do every problem there is possible to do on 515?
Now, it's only going to ask you to find the radius. I want you to find the radius and the interval of convergence.